ITR. Also, we need to configure here the addresses of the IPv4 local locator, IPv4, let me write here IPv4, okay, routing, then locator. We configured it, the IP address of the router 5 IPv4 proxy ITR. Also, as you know, we configured one another things. For example, we configured the ITR, IPv4 ITR. You know that for ITR, we need to giving the ITR the IP address of the map resolver. Because of that, I configured IPv4 address, IPv4 ITR map resolver, then the IP address of the MR or a mapping resolver address, mapping resolver IP address. And also we configured the IPv4 use PTR in the R1, R2, and R3. Here we have another important command. You know that when we are receiving in the PITR a packet with the destination of 192.168.2548, because we advertise this address or the aggregation of this address to router 6, we need to ask from the router 4 the routing locator of the DCID. Because of that, okay, we need to configure one command, the addresses that we can ask from the MR. It's so important. Here we have a command in the configuration of the proxy ITR. This command is the map cache command. Look at here, map cache. So easy. First, you need to configure map cache, then destination, okay, EID, after that prefix. Now here we have three options. The first option is that the drop. I will talk about that. After that, we have another option, map request. And after that, we have another option, native forward. What does it mean? Let me talk about that. Look at here. Assume that in the router 4, I'm configuring this command, map cache, okay? Map cache for the 192.168.2548/32, okay, then drop. This means that if anybody asks about the send traffic to 192.168.2548, okay, you shouldn't ask with the router from the router for the MR about the RLOOK of this address. You should drop it. But if you configure the map request, this means that you should ask from the mapping resolver. But if you configure native forward, this means that you should forward the traffic natively. This is the command we need to configure for the EIDs that we want to ask about the RLOOK of that EIDs from the MS or MR, okay? Because of that, here, we need one new command, the R5, okay? Look at here, router Lisp, conft router Lisp, okay, the command is map cache command. Map cache for 192.168.254. For example, you can configure 2548/32. Okay, the action is map request or native forward or drop. Okay, I can configure the map request. Also, we need to configure for 192.168.2547. And also 2549. That's it. This is the configuration we need. Now we can check the connectivity from the, for example, router 7. If you want, we can capture the ETH00 of the router 1. This is the capture of the ETH00 of the router 1. After that, from the router 7, we can check the connectivity. This is router 7, okay? In router 7, in show IP route, you can see that we have one default route. And let me to use ping with the 172.16.110. This is the IP address of the VPC4. 172.16.110 with the source of loopback 0. Let me to wait some second. Okay. Ping 17. Now we have connectivity. Let me check the capture. This is the capture. Look at here. When we send the traffic from router 7 to router 1 asks from the router 4 about the 172.16.110 and router 110, and router 4 gives this answer, this reply, you need to forward this packet natively, okay? Look at here, in the router 4, in the router 1, if you check the show IP list map cache, show IP Lisp map cache, you can see that for 128.0.0.0-2, this is the larger subnet of the 172.16, for example 110. You need to native the packet for the packet natively, forward native. This is the supernet of the 172.16, okay? And this is all of the class B's IP address, 1 to 128, for example. After that, because of this map reply message, the router 1 encapsulated the ICMP echo to the router, to the PETR, because we configured IPv4 use PETR in router 1, and as you can see, the packet encapsulated to router 5, and then router 5 advertised this packet after de-encapsulating to the destination 172.16.110 that the router 5 learns before than this from the BGP from router 6. Okay, if you want, we can follow the packet. It's so interesting, and also it's so useful for better understanding the OAuth process. Let me to use the follow of the packet here, starting from the router 7. Okay, you know that in router 7 I configured this command ping, then for example 72.16.110 with the source of the loop back 0. After using this command, a packet is created with the source of 171, for example 92.168.2.547. Destination is 172.16.110. This packet forwarded to the router 1. Why? Because we receive one default route from the router 1 in router 7. This is the routing table of router 7. We have one default route from the router 1, and because of that, this traffic forwarded to the router 1. Now router 1 has this packet, and router 1 first should check the source IP of the packet. You know that the source IP should be residing in the EID address space, and because this is one of the addresses of the EIDs of the router 1 can try to forward the packet. The destination IP is not available in the routing table, and also the destination IP is not available in the map cache table. Because of that, router 1, as you saw, sent one map request, okay, to the router 4 about this EID, about the 172.116.110, okay, /32. And as you saw, the R4 sent this map reply to the router 1, and this map reply contained the one order native forward. This means that you need to forward natively this packet. Because of that, the R1 try to forward this packet with the routing table. It can't. Because of that, R1 now encapsulate this packet and send this packet to the router 5, because we configure IPv4 use PETR in the R1. Look at here, show run. Section router Lisp can show us this. Show run section router Lisp. Okay, let me to use the show run also. Show run here. In the router Lisp, we configured the IPv4 use PETR quad 5. This means that if you don't have any pass for a packet after checking the, for example, mapping cache, and also you receive native forward message from the map reply, you need to forward the traffic with encapsulation to this router quad 5. Because of it, as you saw in the capture, this is the encapsulated packet from the router 1 to the router 5. This is the original packet. Let me write here. This is the original packet. And the router 1 encapsulate this original packet and sent this original packet to the router 5. Here we have some headers, Lisp, and also UDP header, and also the new IP header. The new IP header is from the 10.141 to the quad 5. Okay. And this packet now is received by the router 5. Okay, and router 5, after de-encapsulating now these original packets, because the router 5 before than this learn about the 172.16.10/24 with the BGP, it can forward the traffic to the router 6. Look at here in the router 5. If you check the routing table, do show IP route, we can see that we have a path for these networks. Because of that, the router 5 forward the traffic to the router 6, and finally router 6 forward the traffic to the VPC, for example, 4. This is the follow the packet. It's so easy.